okay, here we're going to look at how you are quoted rates and then how to use the rates that you're quoted. A lot of what we've done, not all, but a lot of what we've done thus far have dealt with annual rates, but generally, any contract that you enter into, be it a mortgage, that'll have actually, the rate is monthly, so we would say monthly compounded. So and keep in mind, if I say semi-annual compounding, monthly compounding, that means the period is 6 months, the period is 1 month for monthly, 6 months for semi-annual. So usually your contracts are not, they will have a period of less than a year. So if they have a period of less than a year, again, we say that this is compounded monthly or daily or so forth, if the period's a day, you're given a quoted rate to tell you what the rate is. Now this is a legal way, right, and in many cases a legal way to tell you what the rate is. So the idea here is to first know that if I say, I'm going to have an example here of let's say 1% per month, right? So 1%, the period is a month and the rate is 1%, then you are quoted, right? You are quoted just 1% times 12 equals 12%. So this is the rate that they'll tell you. So if your credit card is 1% per month, right, monthly compounding, then they'll say your credit card has an APR of 12%, right? And APR is a quoted rate. So when I say, I can kind of use them interchangeably. Quoted rate is just a generic term. The APR would kind of be the legal term. There are other quoted rates that wouldn't be termed APRs, like a bond yield, the yield to maturity. This is a quoted rate, so anyway, quoted rate, just generic term for APR. So the idea here is, this is how you're told what the rate is. I tell you, hey, here's your credit card, your APR is 12%. What I mean by that, however, is that you pay 1% per month. That's what I mean, right? If you take away one thing from this, take this away, never use that 12% in the time value of money calculation. So the idea that this is just a quoted rate, it is not an effective rate. Your rate is not 12% per year. What we're going to look at here is 1% per month is not 12% per year. So the one takeaway from this, a big one, is never use the APR, the quoted rate, in a time value of money calculation. You can always just use 1% in the period as a month. Good. So we have a way, if you would like, to annualize the quoted rates to give to get an effective annual rate. And this is most useful if I want to compare two quoted rates. So if you're going to do a credit card calculation, if you're going to do any sort of time value money calculation, I would just highly recommend use the rate per period and then take into account the number of periods. So the idea here is you use, if I give you a bond, just say use the rate per 6 months and then the number of years multiplied by 2, right? So so you can, and so that your period is 6 months. So, but again, we can, if I give you two quoted rates and you want to compare like which is more, then using the effective annual rate is useful. So let's say we have another quoted rate. So we have another quoted rate, right? This would be, let's say we have a bond, right? And it's 6% semi-annually, right? So our APR is again 12%. But these two are not the same. Paying 6% semi-annually is not the same as paying 1% every 12 months. So we can compare these and say which of these rates is more if we, all we have to do is take into account compounding, right? So the idea here is the reason why we never use the quoted rates is it doesn't take into account compounding. So if we want to see, okay, well, which of these is actually more, 6% over semi-annual or 1% 12? Then I have, an EAR calculation here. This would be our effective annual rate. M is, Q is the quoted rate. M is the number of times it's compounded in a year, right? So for this above, this case up here, we would have the effective annual rate is equal to 1. I'll just, simplify it, right? So 1.01. 1.01 to the 12th minus 1, and that should be 12.68%. 12.68, and then we can do the same here with the 6% semi-annually. That will be 1.06 to the 12th, not to the 12th, sorry, to the 2nd minus 1, and that should be 12.36. So pardon my messy handwriting, but 12.68. So the idea here is this is more than that. 1% every 12 months is a higher rate than 6% semi-annually. All right, so if we want to compare two rates, we can use the effective annual rate calculation in general in any time value of money calculation. It doesn't matter. Well, let me phrase it this way. In any time value money calculation, you can use 12.68% annually or 1% monthly. Those two things are equivalent, right? Absolutely equivalent. So you can use this one, you can use this, but never use that, right? Never use the APR or the quoted rate. Similarly, you can use 12.36% is the exact same, and you can show this algebraically, it's not very hard, I'll leave that to you. It's the same as 6% semi-annually, so you can use this or that, 12%, 12.36 annually, or 6% semi-annually, just don't use 12% annually, right? Good. So let me, we'll go through, so this is an exam question. I think this is maybe sort of an exact exam question, right? And why I had that up, one thing I should have mentioned, why it's fresh in your memory. Note that the effective annual rate is always greater than the quoted rate. So, right, so if it's 1% monthly, that's 12.68%. So it's a 12% APR, but 12.68%. 6% semi-annually was 12.36, the effective rate. APR again was 12%. So one thing, if you're calculating this and you get a number, you're calculating your effective annual rate and you get a number less than your APR, you've done something wrong. And that's really helpful again to know that that when you've done something wrong. So the effective annual rate is always greater than your quoted rate. And that's an important piece of information. But here you bought a stock for $100, earned 1% per month for 5 years. What's your future value? So to do this, we would just sit here and say, okay, our future value is equal to $100. Now, like I said, I would recommend just using the monthly rate. So 1.01, so that's 1 plus 1%. And then 5 years, but our period is a month. So that's 5 times 12, 60 months, right? So this would be 60, and what is this? 181.67, maybe? I think that's it. Now this will be absolutely equivalent to sitting here and saying, 100, 12.68%, but I really need to go out farther, more decimal places, but I'll just say 12.68. And if you go out enough decimal places and do that to the 5th power, that'll be the same. That'll be the same. And you can show this algebraically, that they're going to be equivalent. Excellent. Anything else I want to say here? No, one thing, interestingly enough, that maybe this will, a bit of trivia for you here, but like I said, you're quoted an APR, so if you have a savings account, if you have a credit card, anything you pay to a bank will be an APR, and that's how you'll be quoted it. And again, what you pay is actually a little more than what they're quoting you. So if they're saying, hey, you're going to pay us 12% on the credit card, you're actually paying 12.68%, given compounding rate. That is, effectively, you're paying 12.68%. That's the true rate. But they're only quoting you 12%. However, if you go to a bank and you put money in a savings account, they're going to quote you an APY, right? An APY. The APY is what the bank pays you, and that's actually an effective rate. So in other words, when they quote what you're going to pay them, they quote you the lower APR. When they quote what they're going to pay you, they quote the higher APY, right? Which is interesting, or a little bit of trivia. Good. Excellent. I'll leave it with that. Have a great day.